Hi folks, we're going to take a look at number 2 from the Unit 6 assignment. So here they're asking us to find the domains of these three functions, and we see that there are combinations of functions that we know. So here multiplication, here we've got a couple of divisions. All right, so the way we find the domain of these combinations is we have to find x values that are in the domains of both of the two functions. All right, and here when you've got divisions, there's the extra restriction that the denominator can't be equal to 0. So let's start with a here. All right, and since these are just really easy transformations of functions we know, I'm actually just going to use quick graphs to help me out here. So here for the first one, root of 10 minus x. So I'm just going to write that a little differently. I'll write that as negative x plus 10. So I just rearrange that. And then from here, I know I have to factor out the coefficient of x. So this is negative x minus 10. So essentially this function here is just the square root function, which has been reflected about the y-axis and then moved to the right by 10 units. So essentially this function looks something like that. So that means the domain is everything less than or equal to 10. So remember that when you're dealing with square root function, it can be equal to 0. All right. So now here, log base 3 of x plus 2. So I know log base 3 looks like this, just has a vertical asymptote at 0. So the x minus 2, I'm just moving to the left, sorry, to the right by 2 units. All right, so there we go. So it looks something like this, where this is 2. So here I see that the domain is just going to be everything strictly greater than 2. So here it can't be equal to 2. So now I just have to determine the intersection of these two sets. So I can just kind of figure it out in my head, or I can always draw a little number line to help me out. So for this one here, it's everything less than or equal to 10. And for this one here, it's everything greater than 2. So notice here, I put an open circle, everything greater than 2. So the intersection occurs between these two numbers. So here we have that the domain is just between 2 and 10, not including 2, but 10 is included because it is in the domain of both functions. So my domain is just going to be open bracket 2 to 10, close bracket. In other words, from 2 to 10, not including 2, but including 10. All right, so let's move on to the next one. So I look at my numerator function, and sine x has a domain of all real numbers. 2 to the 2x minus 2 to the x plus 2. Well, here, there's no restrictions on what I can put into x, so the denominator has a domain of all real numbers. The only thing I have to be careful of is because I'm doing a division, I need to make sure that this is not equal to 0. All right, so let me see if there's any values of x which make the denominator equal to 0. So I'm just going to solve 2 to the 2x minus 2 to the x plus 2 equals 0 and see if there's any solutions. All right, now here I have an exponential equation. So there's a couple of ways of solving this, but I notice here that I can just bring this to the other side, and look what I can do. I can just write this as an equality of 2 powers with the same base. All right, and of course, if 2 powers are equal and they have the same base, their exponents must also be equal. So I just have that 2x must be equal to x plus 2. And so here, bring that to the other side, x is equal to 2. So this is the only value of x which makes the denominator equal to 0. So my domain, okay, is going to be all real numbers except x equals 2, okay? Or if I want to write it in set notation, I could also do that. X in R such that x is not equal to 2. That would be an alternative way of writing it. Okay, but here again, I determined that numerator and denominator had domains of all real numbers. The only thing I had to check for was when the denominator was equal to 0. All right. So here again, the first thing I'm going to do is let me find the individual domain. So here, log of negative x. So again, log of x looks like this. So log of negative x is just going to be a reflection about the y-axis. So my domain is going to be everything less than 0. Okay, and then of course root x is everything greater than or equal to 0. So even before I consider when this can or can't be equal to 0, I notice there's no intersection between these two domains. these two functions are never defined at the same time. So what does that mean? We can say that the domain is empty. Okay, there's no elements in the domain. No elements in the domain. Okay, so essentially what does that mean? It means this function is never actually defined. All right, we do have a symbol for it, something we haven't seen before, but this is what we call the empty set. Okay, although I'd be perfectly happy if you gave me a description instead. All right, so if we just go back and take a look at our strategy here, we notice that the combinations are all products and divisions, and it would be the same thing for additions and subtraction. The first thing you have to determine is what x values are in the domain of both functions, all right? And then if it happens to be a division, you also have to consider when the denominator is equal to 0. Okay, that's it for this one.